let's talk about the greenhouse effect. We're going to take a very simple look at the greenhouse effect. This is a very complex subject, but let's look at it from the heat transfer aspect. First of all, remember that everything radiates heat. You radiate heat. An ice cube radiates heat. And remember that the wavelength of the radiation depends on the temperature. So a hot object with a short wavelength and a cool object will have longer wavelengths. We're going to use, for this example, just two different short versus long wavelengths. And the short is visible and the long is infrared. Clearly, we can move to different parts of the electromagnetic spectrum, and visible light would be considered to have short wavelengths. So, would be considered to have long wavelengths. So, for this discussion, we're just going to use this explanation. Now, air is transparent to visible light. All that means is you can see through it. And it turns out it's also transparent to infrared. So infrared goes through air very nicely. There's no problem until the air has extra carbon dioxide and water. When there's extra carbon dioxide and water, you can't see through it. Let's think about this. We can't see through rain very easily. We can't see through smog very easily. Well, it turns out infrared doesn't go through water or CO2 very easily either. Now, imagine the sun is up here shining down on the earth. Here's the sun, and it's shining down on the earth. The sun gives us visible light. The visible light comes on in. We're happy with it. It goes through the atmosphere, and it heats up the surface. Yay, we like that. We're warming up. The surface, in turn, gives up its own radiant energy, and it gives up radiant energy because everything emits radiant energy. Now, because of the excess water and CO2, the infrared can't get out. So it gets trapped. And because it's trapped, it is actually heating up this surface. So you wind up quite literally cooking yourself if you get too high of CO2 levels.